Today we're going to talk about specifically bridge demolition. There's a few pictures of previous schemes we've been involved with, which gives an idea of the depth of our experience. From the left, you've got Locker Viaduct, which was a viaduct over the estuary in Locker, South Wales. Reading Station in the middle. Down below is one of the M25 or A13 bridges. I can't remember which one that was. Up in the top right is Crossrail. That was Whitechapel Station, and bottom right is Churchill Way Viaduct, which there's many presentations we've given on the subject of Churchill Way, so I'm not going to cover that in too much detail today. So bridges, they come in all sorts of shapes and sizes, from very, very small 1 metre spans, maybe over a culvert or similar, to structures a mile in length. The materials they're made of can have a huge impact on the demolition methodology. If you just think about a concrete bridge and the variety of different construction forms you have, just with concrete, you've got precast, you've got in situ, you've got hybrids where they've used precast elements to be a permanent formwork. There's mass concrete with older viaducts and parts of more modern structures. Then you come into the world of pre and post tensioned. Pre-tension being structures where the tendon is placed in tension, concrete's placed around it, and that locks the stress in. Post-tension, where you cast your concrete form and then you apply a post-tensioning force to it. We've covered that in details in many other presentations we've done. So if you want to go and read about the challenges specific to pre and post-tension structures, it's all there for you. Steel, you have mild steel and you have high-grade steel. Doesn't really change too much how you deal with those, but it's something to be aware of. You have composite bridges, so where you have steel girders that are restrained by a concrete deck, that's a composite construction. Masonry, so typically arches, that is often masonry elements on a lot of other bridges. Reinforced masonry, not something you generally come across, but it does exist. Timber bridges, we've dealt with a number of timber bridges, generally footbridges. But you do also get timber highways bridges, not very common. Cast iron, still quite regularly coming across structures with cast iron beams in them still. In fact, there's an interesting one we're looking at the moment where the cast iron beams have actually fractured already, which is interesting when it comes to track protection. And then there's wrought iron structures as well, and they're generally the main materials that you're going to come across. Now, the constraints are the things that make the job more challenging. And here's just a few highlights of what we would consider as constraints. So railway over or under, that instantly means you're looking at railway possessions, closures, planning for short blockades, etc. Same with roads. If you're looking at working on a road, you're going to be needing to get road closures, all the planning that goes into that, the height of the structure. So if it's a fairly typical clearance, or if it's maybe over a ravine or similar, that can make a huge difference on how you approach the structure and how you demolish it. The condition of the structure, whether it's in good condition or whether it's in very poor condition, can make a massive influence on how you deal with it. I've touched on this already, but time, railway possessions are expensive and have to be planned well in advance, and you've got to make the most of them. Road closures are fairly similar. Time of year can make a big difference. So if you're planning to do a demolition scheme in the summer, you are quite likely to worry less about wind cranes being winded off, because if you're planning it for the winter months, then cranes being winded off becomes a very real risk, and then you need to make sure you've got contingency in there. So I've been able to use machines to complete works, or you've got to look and make sure you've got second weekend or third weekend booked in place should you be winded off for the first weekend or whatever it is. If you're working over a tidal estuary or something that floods, the water can play and the amount of time you have available to work. Simple things like Christmas and Easter, not only does it change the cost of the work, because if people are expected to give up their Christmas or their Easter break, they're going to want to be paid more money. It also puts pressure on those resources that are available. So if you need a crane and there's only one of those cranes in the country, you need to be booking it 2-3 years in advance to make sure it's there for you. Services can make a huge impact. Quite often you'll find that services are diverted that might be onto a adjacent service bridge or footbridge. If that's the case, there's still a constraint, it's just a different constraint. Often, the service cannot be diverted at the timescales you have available. So you end up having to support the service in place over the existing structure while it's demolished, which brings its own challenges. Services above the structure, also a big problem. So things like overhead high voltage cables can cause big problems because it's very unlikely you're going to be able to divert them. If you work on the railway, the OLE and the third rail is not too much of a problem, as long as it's isolated, obviously. OLE, the time it takes to raise and lower OLE can have a huge impact on the program for the works. Sometimes we're only demolishing part of a structure, so we've got to protect and retain other elements. There's adjacent structures, whether that's a brand new bridge built right next to it, or a temporary footbridge or a temporary service bridge right next to it. It all makes life more difficult. If you're putting scaffolding up ready for the rebuild works, it can make the demolition far harder. Rivers and estuaries we've talked about. Sometimes it's what plant you can get and how close you can get it. Could be weight restrictions on the bridge or weight restrictions approaching the bridge, or simply just not access for heavy plant. Ground conditions, particularly if you're using cranes, can make a big difference. So just going to touch on a little case study here, which is Lton Court in Bristol. And I've chosen this one, not because it's the most impressive, but because it's got lots and lots of constraints. You can see straight away there, the pylon, which meant that the cable was going directly over the top of the bridge. So I should have mentioned this. We did this for Sam Gilpin Demolition. We were working for Hockteeth, we were removing the steel footbridge on the side of this highway's masonry arch. It was also, in terms of constraints, it was very high. I think it was probably 40, 50 meters from the track to the bridge because it bridged across the ravine. Railway under was obviously a constraint, and the access for plant was limited because the approach roads were quite tight and had weight limits on them. So the scheme we came up with was, taking account all these constraints, was to support the edge girder in place with some temporary works, and then use zero tail swing machines to lift out sections of the bridge. So this is the masonry arch that the temporary works sit on. You can see the edge parapet there, and then off the side is cantilevering the steel footbridge. So it had a parapet, had a plate girder down one edge, and was supporting the other side with steels projecting into the masonry structure. So the sequence was to put temporary supports in, as you can see there on the elevations, then cut out piecemeal sections of the structure and lift them away with the excavator. So pick them up and move them sideways away from where the cables, the overhead cable exclusion zone was, and lift it up, and then working through a detailed sequence to make sure that the bridge would span and that it would remain stable during the works. And as you can see, and then the process just continued working its way out, gradually taking the weight out of the structure, and that allowed us to demolish the bridge, taking into account all the constraints on the site. Required quite a lot of in-depth analysis to achieve it, but it was achievable, and they completed the work safely. It's a few years back now, though. So we've talked a bit about the constraints. Let's talk about the methods. So typical methods for bridge demolition, probably the most popular is mechanical demolition, which I mean using breakers or similar on excavators. Second most popular, I would say, is probably cutting and lifting. And then you're down into the realms of explosive demolition, which isn't very common for bridges, particularly in this country. And probably becoming more popular is removal with SPMT or similar. SPMT being self-propelled modular transporter. Often you'll use a combination of all of these, well, not explosives, but you'll use a combination of different methods to approach the demolition. So let's start off with methods of cutting and cutting sections free on a structure. A good starting point for that is diamond wire sawing. So as you can see there on the right, that is a diamond wire saw. That chain there, or chain, the wire there, is what cuts the concrete. So it's got a series of links on it, and the links are diamond encrusted. So not diamonds that are mined, diamonds that are grown in a lab generally, that are bonded onto the wire, and that wire is an abrasive and basically wears away the concrete. It'll cut the reinforcement, it will cut many different materials if you wanted to. Typically more often used on concrete. Downsides with it is generally water runoff, though you can do dry wire cutting, it's just not very common. Floor saws, is a floor saw there. So as you can picture, you've got a big steel disc, and again, that's got diamonds on the tip, and that is what cuts the concrete by the abrasive action. Again, generally you need water, which means slurry runoff. And it's pretty much as it looks. You start the blade and you cut along the structure. So that's well suited to where you've got a nice flat deck or something similar, where you can just work your way along cutting. Track saw is quite similar, except instead of being mounted on wheels, it's mounted on a track, which you can see there. They fix the track in place and then they run the saw along it. When you're dealing with steel, wrought iron, then you start talking about burning, providing there's no constraints on burning on site. So that's the simplest way to cut through steel sections, is with a gas axe. Obviously, you've got to be able to get close enough to do it, and you've got to consider the position of safety for the people who are doing the works. Thermic lance, I don't think we've used it when we've been cutting bridges, but you could do. Particularly well suited to burning things that are quite heavy sections. So a thermic lance, as you see there, is a steel tube generally, which has oxygen running through it, and then you have either magnesium or iron or aluminium rods inside it, and you set fire to it, and that will literally burn its way through anything. It could be 3 foot thick steel, but it will burn its way through. It will just take a long time. So if it will cut pretty much any material as well, but generally used for processing large, thick sections of steel. Cold cutting, so that might be recip saws, that might be through using other handheld saws. The blade technology has come on a long way with these now, and we've worked on a number of schemes, large schemes, not necessarily bridges, but things like gas holders, where you're not allowed to do any hot cutting on the site because of the potential for fires. And with the modern tools and the modern blades, you can rip through steel very quickly, cold cutting. So it's not one to be instantly discounted. It can be quite a powerful tool if required. Breakers, so that's a hydraulic breaker. You can see there the tip of the breaker is forced into the concrete at high pressure, and that fractures the concrete of the reinforcement. Water jet cutting. I don't know why I didn't put it here, but you can also use a muncher to do the same thing. So instead of propelling a steel breaker tip at the concrete, you crush the concrete. I do cover it later, but I should have shown it here as well. Water jet cutting, again, not very common, but can be used at very high pressure water, generally with an abrasive mixed into the water, can be used to cut sections, and that can cut pretty much any material. Obviously, you get a lot of water runoff, and you've got to have a high pressure system on site, but it's all achievable if the constraints require. Hydro demolition, not typically used for large scale demolition, but if you've got to keep part of a structure, and in particular you need to expose the reinforcement, as is being shown here, you can use hydro demolition to basically wash the concrete away with high pressure water, exposing the reinforcement, so you can then tie the new structure into it. Explosives, you've probably all seen this in the news a few days back. This is in Baltimore, where they used cutting charges to dislodge part of the bridge structure that was still stuck on the boat. We don't tend to use cutting charges much for bridge demolition in the UK. They do in America quite a lot more than we do. I don't think we tend to use cutting charges very much, maybe for industrial demolition, like power stations and things, but not generally bridges. We do, however, use explosives for demolition of highways, bridges in the UK. This is one from A38. This was Gilpin's again, where they chose to use explosives to drop the deck. You'll see a video of this later. So it could then be processed with machines. And there we're using the explosives to fragment the concrete around the tops of the columns, and that allowed the bridge to then drop down to the road protection below. So methods for lifting, you can obviously use cranes, whether that be a crawler, mobile. You can use an excavator with a grab attachment. They can be very, very useful for dismantling structures. You can also use an excavator to lift as there. So that's been pre-cut with track saw, I believe, from memory, and then core holes through it, and then lifting the concrete sections out. SPMTs can be used for lifting sections of bridges out, and that's becoming more popular, particularly if you can reuse the SPMTs to lift the new deck back in. Barges can often be used to move bridges around and to demolish them if the constraints suit and you've got a suitable body of water. Strand jacks for lowering sections. Again, I don't think I've ever done a job where we've used a strand jack to demolish a bridge, but it's possible. Just we haven't done it. So jacking itself, which you can see the jack units there. So that could be used to raise the deck up, then move the deck and then lower it back down again. So each of those cassettes there can be, so it lifts it or lowers it, then you can take a cassette out and then you just repeat the process, or the opposite to lift again. And sometimes you use a combination of both. So you can see here that this bridge is, on this end it's on SPMTs, on that end it's on the barge still, and it's being slid off it. So yeah, sometimes a combination. For traditional demolition works, you can use a shear, as you can see there. Right machine with a big shear on it is a sight to behold. The section size they can physically cut through is quite impressive. And on this job here, I think they were running I don't think I've got a picture of it, they ran a 70-ton machine with the 15-ton shear on the boom, direct on the boom here, and that crushed and went through the top chord of that bridge without any trouble whatsoever. Whereas if you were using a smaller shear like that, you would struggle somewhat to crush the or to break through the top chord of that truss. A muncher, it's not a really good picture because it's cloudy, but there's a muncher on the end there that's physically crushing the concrete deck. Breakers we've touched upon earlier, which we've touched upon earlier for traditional demolition. So this is an example of explosive demolition, where the idea was to drop it to the road to allow it to be processed with machines. Not that common in the UK, but it does happen. This was, I say, this was the A38, probably 5 or 6 years back now. And the reason it was done like that is because of the amount of time they had in the road position. That it was the only way they could have possibly done it and cleared the road and got out there in time was by dropping the deck down and then being able to smash it up on the ground. Our role on the scheme was we provided the protection to the road, and there was a number of sensitive services that we had to protect as well. It was quite an interesting one, and you'll see the kind of road protection that we designed for that, or part of it anyway, in a later example. Example of cutting and lifting and mechanical demo. So the drop span in the centre was lifted out of the machine, and then the rest of the structure was then demolished using mechanical methods because it suited to the methodology suited that particular bridge structure. This is just an example of specialist lift beams that we've designed to facilitate the removal of quite big sections of a bridge. So we wanted to take out, I think it's 1, 2, 3, 4, 5 girders, might have been 6 girders in one go. And we designed a lift beam that had the required flexibility to allow the demolition contractor to do that. And it worked really well to facilitate that. And it's just a section being lifted out with a mobile crane, fairly standard demolition practice. And there you go, you can see a pulverizer or a muncher there that was used to demolish this ramp access at Barking Riverside quite a few years back now. So a big part of the demolition can often be asset protection. So if you're going to demolish a structure, you've got to protect what's to remain. Good example of that is the A38 Merrifield, as I said, where we had to protect the road from the impact, and we also had to protect a series of services, which I haven't shown the detail of, but that's in cases like that, you're going to be bringing in quite a lot of crushed material to make a nice absorbent pad for the bridge deck to drop onto. It's not going to be suited to just drop it onto navy mats when you're dropping that sort of weight of bridge structure. If you're working on the railway, then if it's a underbridge or overbridge, underbridge, then you're going to be protecting the railway itself from the impact load and the demolition. Generally, 150mm deep navy mats are going to be adequate. But again, you always have to think about what it is you're doing and what is the potential for impact on the structure. It's not just a case of one size fits all. It's thinking through what could happen and making sure that you've protected the railway adequately. Typically, if it's an OLE area, you'll be dropping the OLE, split ducting it, and putting it under the road, under the navy mat protection. The important thing to consider when putting in rail protection is that you don't load the rail heads directly. That's frowned upon by the permanent way teams. If you go back 20 years, that's exactly what used to happen. But now we bridge over and make sure we're not directly loading the rail heads or the sleepers or any other assets. Generally, we try and put the load into the ballast directly. Sometimes when you're doing traditional demolition, the road mats or navy mats are not going to be adequate. Again, this is a case where you have to think about what it is you're doing and how you're going to collapse the structure. So this was a post-tension structure, and the structural form was such that we were concerned about trying to deal with it in a conventional manner. So where you try and take all the weight out of it in the air and then instigate a collapse quite late on. In this case, we wanted to weaken the structure and collapse it quite early and then deal with it when it was on the ground. So for that reason, we put in this greater level of road protection, including large piles of it, specifically where we were going to hinge the bridge and cause it to collapse. This was one of the M25 bridges, I can't remember which one, but that was completed, and you could see video of it online that it worked quite successfully and protected the road from the impact, and everything was done safely, which is, after all, what we're all trying to achieve. Sometimes as assets you need to protect, like a little signal cabinet or a little door signal or similar, and then it's a simple case of building a lightweight timber box around them. Obviously it's got a lid, I just didn't show the snapshot with the lid. Just something that's going to make sure of the likely impacts it's going to be protected against. Obviously, if that's directly underneath the bridge, it's probably going to need more protection than if that's just outside the bridge. Again, it comes down to looking and thinking about what needs protecting and to what level, but at the same time keeping it simple so the guys can put it together quite quickly on site. Again, it's always about keeping things simple, because with bridge demolition you're normally working against the clock. Very rare that you've got an unlimited amount of time in which to protect a structure and demolish it. So here, stacks of navy mats and then navy mats over the top just to protect the concrete road barrier that was to remain in place. And simply for things like services where they've diverted them into split ducting, making sure they're properly protected from any likely impacts. Again, typically navy mats are going to do the trick. Although you wouldn't believe the number of times we've had to discuss whether navy mats work or not with check-in engineers. This is really kind of a point of learning. So what the law says is that generally, if you're demolishing a structure, you should process it on site, and then move it as rubble off the site. Now, sometimes the client may dictate, as they did in this case, that they want it moved off site in large pieces and then demolished and then crushed at another site. That is not necessarily good practice, but that is what some clients request because they don't want you crushing concrete in a city centre environment at night. Now, this happened during the Regent Street flyover works up in Leeds, where the beam had been safely removed and then it had been put on the back of a lorry. And as the lorry was just about to leave the site, they had a failure of the axle, some of the axles on the trailer, and the beam dropped to the floor, as you can see here. So this brought about an interesting point that was kind of came out of, well, as part of the learning from the event is at what point do we as engineers, temporary works engineers, are we no longer responsible? How far should we go? Should we be thinking about how these loads are strapped down? Not that it had any real bearing on what happened here, but it's more the process of if you know it's being transported off site, where does our role stop? What do we have to do to make sure that the job is delivered safely? Is it the edge? Is it as soon as it's on the back of the lorry? Is it someone else's problem? Or does it go further than that? And interestingly, a job we did recently with Balfour Beatty, who were actually the principal contractor on Regent Street, they requested that we designed and detailed the strapping arrangements on the back of the lorry because, in this case, it wasn't going on an open road, but it was being transported from where the bridge was being demolished to a site, one of their compounds about a mile away, to then be processed. Now, as some of the learning from there, they asked us to produce a strapping detail that could be given to the haulier to make sure that it was loaded properly and safely and would make the journey without any issues. The key thing with that being communicating the COG, the weight of it, and then how you would envisage it is strapped down. And it was quite an interesting process actually to work out how many straps would be required, trying to estimate the sort of load you could get due to braking, acceleration, going around bends, etc. It was quite an interesting process. And it's the point to think about is where does your role stop? And if you know it's being transported, should you be involved? I don't know where you stand legally because the legal responsibility for strapping the load down lies with the haulier. So it's perhaps just something to think about, I think, more than anything else. But interesting to see that Balfour Beatty asked us to look at it in that level of detail, nonetheless. So now we're going to go through a few case studies. Some of these are a bit of a blast from the past, but they were interesting jobs, very interesting jobs. So I've talked about this one briefly. This is Locker Viaduct. I think it was 270 metres long out in South Wales. You got to Cardiff and you thought you were almost there. You weren't. You were still 2 and a bit hours away from it. It was a long old trek out there. It was timber bents and then steel plate girders all braced together. Had a timber deck, ballasted timber deck, and it was to be demolished in, I think they had a 100-hour possession, and for a 270 metre long structure over an estuary that you'll see in the video shortly, how much the water rises and falls during the tidal range was quite a challenge for some of the Gilpin's team. It was interesting in that the new bridge had been built offline next to it, and that was sitting on these new permanent and temporary supports. So once we demolished this, the whole bridge could then be slid into place, which is quite an interesting concept. But what it did do was it gave us somewhere for us to sit our plant to facilitate the demolition. Otherwise, you'd have been working from the middle back out, which would have had wouldn't have been that easy necessarily. So the basic concept was to have 3 crawler cranes running on the new bridge with a good degree of separation. You see there, we've come up with limitations on how close together plant can operate to make sure that we didn't overload the permanent works. in the temporary condition. The new deck had actually had all the rail at the track laid across it and ballasted, so we had to put track protection down on the new bridge to operate off. And then it was a case of cutting it free, lifting it off the middle crane loaded barges, the two outer cranes loaded lorries, and it was a process of getting on with the job and keeping going. It's a little 3-minute video here that I'll let play. See what I mean? You can see what I mean there about the tidal range.
The major challenges is the tidal constraint and the difficulties of working over the flowing water, and also most of the work has been done with cranes, and they're wind sensitive. Why'd you do it? Well, we got started in demolition, well, nearly 30 years ago now, so it's been a natural progression from knocking down buildings and sheds in the quarrying industry. We sort of evolved into the rail industry and specialised in bridge demolition and the marine aspect of demolition as well, working off barges and working with boats and working on the water and the tidal waterway. Although it's tonight, being out here at 2 o'clock in the morning when it's freezing cold on a Saturday night, I don't think love comes into it. We're just about to start burning out the first girders now. Oh yeah, we've only got another 53 to go. Finished the bridge deck 25 hours early, well ahead of schedule there. Not very well.
So yeah, that was one hell of a scheme that they did. And if you've ever met Sam, he loves nothing more than to be driving a machine. But he's a hell of a character, and that was a hell of a job they completed in the time they had available. That finish early was some achievement, that one. This one's a little bit more recent than that. So this is oddly green, but again, it had some interesting constraints to it. You had an existing footbridge to one side. You had no illegal gantry very close to the side of the structure. And you had the new bridge had already been constructed here. And then once this bridge was demolished, the next new bridge was built here. So jack arch construction with mass concrete, and they were reinforced concrete jack arches spanning between steel girders, which then spanned from trestle bents to trestle bent. So we only got involved in the second phase of the demolition here, because during the first phase, the engineers they used put a lot of temporary works into the structure, which made it very difficult to do the demolition. We came at it with a different approach, which meant there was very little in the way of temporary works required and allowed the demolition to be completed a lot faster, which is always important. Particularly here, as you had 4 tracks, and you had a lot of OLE to lower, and it was quite fragile and old OLE system. So there were concerns about how easy that's going to be to do. So track protection went in, and then we put plant on the deck, working its way back, breaking out the outer girders, and then the inner girders. They worked their way back. And then as they could, we used the grab on the machine to cut and lift out the steel girders. And then working your way back up to the abutment. Now the abutment, the new abutments have been built behind the old abutments, which, as you'll see in a minute, made life a bit harder. We worked out the weights of all the girders, gave them options for lifting with a crane. In the end, most of it was done with excavators, but the option was there for a crane, and the level of planning was right down to making sure that the machines could actually reach what was required and had the capacity to lift at that radius. The new abutments behind meant there was a gap. So this is the new abutment here. Meant there was about a 3.5 meter gap between the new abutment wall here and the old structure. So we had to put a bridging structure in to allow the plant to operate. And that was the main change we made, that then allowed all the works to be done with machines. It made life far simpler for the guys on site. Interestingly, though, we would design that for Hockteeth when we worked for the demolition contractor for the demo sequence. It was a bit of a strange one, but there you go. Why is it not in full screen anymore? There we go. Right. Here's a little video of it. That one in action, scheme in action. You can see there, this is the new abutment. This is the old abutment, and this is the Navimat bridge system that we put in place. Same each side, actually. See all the decks being marked out, so there was no confusion as to what was being broken out where. Navimats put down in the right place with scaffold boards to make sure we loaded the steel beams. Breaking out the outer decks first, then taking the steels out, working your way back, lifting. See there, the girder's being lifted out and then clearing the track protection below. The advantage of being able to sit on that little bridge meant they could clear the track protection up and out rather than taking it out around a ramp, which would have been a lot harder work for them. You see how close the new bridge is, and the footbridge on the other side as well. There you go, hoarding going up. Job done. I think you see the trains passing again. Job well done. Again, another quite challenging scheme to deliver in the timescales they had available to complete the demolition. And that was Clark Demolition who did that one. This would be Highbury Corner. Another very, very challenging scheme. A very constrained site. You got the East London line, the North London line. Coming across the page here, you've got the Victoria. Is it Victoria? I can't remember which tubes you got deep down. You had old structures here. You had the station. You had pubs that had basements. This section was very, very heavily damaged. In fact, over there was a number of buildings that were demolished. Not demolished, they were destroyed by a V2 rocket. And they just lay there dormant for many years. So there were an awful lot of constraints to deal with on this site. It kind of puts it in context. You basically had 2 tunnels effectively with a big central pier in the middle, which contained vaults. And we had to take out, or the phase that Sam Evans did was take out this section, and Network Rail decided to keep the damaged section, which is over here, because it didn't need to be replaced. So, but they placed some significant vibration limits on us to prevent damage to that section there being retained. This section here was demolished and replaced in an earlier phase. Gilpins did that, and then Sam Evans did this phase of the works. Looking at it in section, you had masonry jack arches, and then you had a steel deck with deck plates, and then you had trough deck here, and then you had a steel deck in the interface at the end here, and then you had jack arches again, and these had tension ties installed as part of the permanent works in advance, so there was no danger of that moving. These were cast iron beams, as were this one here, and this one here was cast iron, and the rest was steel or wrought iron. I can't remember from the top of my head. To facilitate the works, it was felt that if we demolished it, excuse me, in the traditional manner and dropped it into the tunnel, it would be very, very difficult to clear. So if you put the track protection down at track level in there, it would be very, very difficult to clear up and get the rubble out. So we proposed a crash deck was installed out of it was Titan or similar, or Alshore, one of them, and this had another part. It played another part. There was concerns from the permanent works engineer that the abutments would become unstable when the decks were removed. We didn't necessarily share in their fears, but nonetheless, what you can't see there is that the header beams further down are super slims, and they had jacks on the end, so they were jacked out to the walls, and then the deck was built on top, so they propped the abutments and they formed the crash deck to allow the demolition to be completed, and it worked really well. Quite hard work to install, but it did the job it's required to do. You can see there the demolition in full swing, where the deck's been exposed, and the areas that are being kept up here, and just how congested a city centre site in London can be when it comes to starting the demolition works. And there it's a bit later on, again, full phasing and working out the methodology to allow everything to be removed and work your way back and still be able to get out and get all the rubble clearing away. A very interesting site, and another one where we actually provided site supervision for Hockteeth on that one. Like most of the ones I've shown, actually, we were at Locker, we were at Hardy Green. It was an interesting Christmas, that one, that's for sure. There's a video there. And that just about brings me to the end. If you want to learn more about demolition, temporary works, there is a whole lot of guidance out there in the industry. There's the Temporary Works Forum, has lots of useful info. 5975, Safe by Design. I haven't updated that snapshot there. That's my mistake. I know it's the Safe by Design from Network Rail is useful. The NFDC guidance is useful. Temporary Works Toolkit, which was in iStruct T magazine. This book here, Temporary Works Principal Design and Construction, has a lot of info. The Institute of Demolition Engineers has got a lot of useful stuff on there, and our series of YouTube videos now, which is basically just this webinar recordings. I don't know, was there 90 hours now, Chris, isn't there?
There's 91 videos, and there's
91 videos
yeah,
of excitement, pure excitement.